Why does it start raining every time I'm trying to make a video? Yeah. And we also have negative 6 amps outside, because it seems like we are using more energy at the moment than our solar delivers. Well, that's why we have a battery, huh? Okay, in today's video, guys, we want to have a look at the Yixiang do-it-yourself battery. There it is. A couple of months ago, we built this beautiful battery box here. It's a do-it-yourself battery, a pre-assembled do-it-yourself battery case. You only need your own cells, which you can order from Yixiang as well, by the way. And then you put everything together and have your beautiful battery up and running in no time. And we didn't have much to complain about this do-it-yourself box here. It comes with a 200 amp JK inverter BMS, flexible bus bars, these PCBs for the balance cables, and a really nice front panel layout. The only complaint we had was this circuit breaker. Yeah, it's a bit of a flimsy one here. And it didn't quite seem to be up for the task to protect such a battery. But apart from that, this whole system got almost 5 frogs out of 5. Very, very nice and almost perfect battery box. Guys, welcome back to the Off-Grid Garage here in sunny, sweaty, hot Australia. Man, I tell you, today we are just getting some clouds here in the afternoon now, and thankfully it has cooled down just a tiny bit. I've got the fan here running all day long in the garage, and it makes a nice breeze here through the garage. Even the air is pretty hot. Okay, in today's video we want to have a look at the Yixiang do-it-yourself battery box, but not this one here, because there is now an upgraded version 2 of this battery box. And I've just unpacked this one this morning here. So we want to have a look what kind of improvements they have made and if they actually be able to earn 5 frogs now. Let's have a look. Let's see if we can. Okay, my friends, there it is. The new upgraded Yixiang battery box. Ooh, what can we see here at the front? The layout. Let's get the other box next to it. Now we've got both boxes next to each other, the old one and the brand new style. Immediately we can see the upgraded circuit breaker over there. The BMS communication boards have moved a bit to the middle now. This is all centered now, while here it was more on the left and the writing on the right. This here actually seems to be a bit more cramped just because of the logo. But apart from that, display in the middle, on-off power button in the middle, 2 positive, 2 negative terminals here on the side, same as over here. They now have changed to clear terminals, but we now have a nice updated circuit breaker. 250 amp, it has a trip function to test as well. Not too much has changed from the outside. And the dimensions seem to be the same as well. Let's get my salt stock and measure the old box here. 435, and here we have 435, same dimensions. The next thing we can find are the ventilation holes here, left and right. This is basically in the front compartment where the BMS and all the connections are. We now have ventilation holes left and right. So there's actually a bit more airflow now inside this small compartment. All the cables, the connections, everything gets a bit warm. So now we have ventilation. Especially here in Australia we have lots of insects, lots of little critters and lots of dust as well. So I'm always a bit skeptical about ventilation holes, you know. I'm building my battery and system room here as air and dust and insect tight as possible. And now we've got a battery case which has ventilation holes. Should be fine, because once this box is inside this room here, there will be no insects anymore. Okay, let's get a Phillips bit screwdriver, open this lid and have a look inside. Thanks for using Phillips bit. The battery box also comes with these 2 stickers, as well as the manual how to build this battery in this little booklet. And look at this. Pictures, a bit of text, simple steps, 1, 2, 3, 4. Just follow these instructions here to build the whole battery box. This is what I really like. See, it tells you here in what position the cells have to be installed inside this battery box. PCB A, PCB B is clearly marked. Oh, this is actually interesting. This is the assembly of the balance cables at the BMS. and it is 1, 2, 3 and 4. So the order is completely different from what we have seen before with these BMSs. Yeah, let's check this fine and new detail here once the front plate and compression plate is disassembled. And furthermore, there's also a QR code you can scan to watch the installation video. If you still have questions how to build this battery, just watch the video. Brilliant. Perfect. And here you can also see the lid of the old case and the new one. They are 100% the same. So even these holes here for the feet are in the exact same location. And this was a bit of my concern when they announced a new battery box. I said, what is happening when people have already an old one and want to buy a new one just to extend their battery capacity? And they said, no problem, it is all compatible. So we can stack old version and new version on top of each other. It is the same dimensions of the case. They only added the ventilation holes, the circuit breaker, bit of design change on the front panel here, and that's basically it. Everything else should be the same. No, it's not. Because as you can see already here, we also have now a fire extinguisher inside this battery box, yeah? This is just one of these aerosol extinguishers, you know, when you have like a cable fire or something. This one will actually release some gas inside and extinguish the fire. Because we all know lithium iron phosphate batteries are actually very, very unlikely to start a fire. And honestly, these extinguishers are a bit more peace of mind, you know. But it is a nice feature they have now included in the box. In comparison to the old box, I can also see they have swapped now the A and B PCBs for the balance cables. A is here on the left side and A is here on the right side. So there's a bit of a design change between these boxes. So we're taking these ones out. We have the box for the JK inverter BMS here. It is a PB2A16S200, 200 amp BMS with a 2 amp active balancer, and these are all the accessories. No, actually not. They put the bus bars in here. No, well, fair enough. Because the JK BMS already mounted and cabled correctly here inside this box. This is all pre-configured. Look, all the cables are already installed, connected. It looks really, really nice and clean in here. I like it. And we also have tons of sticky foam, EVA tape and epoxy sheets here to cover this whole battery case inside. From memory, nothing has changed here with the battery case itself. It has a middle support between the cells, which I always like, because it holds the compression plate here at the front, not only at the sides, but also in the middle. Everything is nicely welded. There are no scratches, no paint missing anywhere. See, all the welding spots are nicely covered with paint. This is all very nice and high quality workmanship. So I think we have to take out this screw here to disconnect the cable to the BMS from the bus bar. And then we can take out this front plate. Yes, this is the only bolt you need to take out to get access to the BMS and compression plate. What I can see now, they have changed the complete layout inside. They're not having the main negative on this side anymore, but on this side here. While here it is the exact opposite. This is main negative and this is main positive. So battery number 1 is over here, while battery number 1 is here on the right. That's why they have changed the balance cables here as well. So they're starting with number 3 and number 4 here, and have number 1 and 2 on this side. This is a bit confusing. I really would like to see the numbering here changing then, because the BMS still says battery 0 is here at the bottom, but this is where you connect your connector number 3, and this could be a bit confusing. Even it is all pre-wired and pre-configured, pre-connected, it is still confusing. So I would really recommend to change the numbering here on these balance cables. Make this one number 1, number 2, number 3 and number 4. So there's no irritation, no confusion, and everything is in the right order then. Alright, compression plate with BMS comes out. There we go. And this is pretty much everything you need to disassemble. Now put your batteries inside and then screw this one back in. You don't actually need to take this out altogether, because they're using such long screws here, you can actually just loosen them a bit, and then you can install all your battery cells plus the EVA tape in between each cell, and you don't have to take it out altogether. I just wanted to have a look at the overall quality here, see how this all looks like. It is all very, very good. I like it. Nice quality. So I also want to check on these pre-configured cables here and what torque they have used. Alright, 0. Yeah, around 4 Newton meters. Yeah, 4.3, 4.5 Newton meters around. I'll just check them all. Yeah. Oh, this one actually... This one is a bit less here. So I'm not sure if they have actually torqued these screws. Oh, this one moved. Now you've got 4 Newton meters. So there's a bit of inconsistency here with the torque of these screws here. And it says it in the manual actually to check all the screws because they may loosen during transport and everything. I'm not sure if they really get loose during transport. It is more like an insurance for them because they said, well, you should have checked all the screws. They explicitly mentioned the screws here for the breaker though. Let's check the main positive here as well. Yeah, around 4 Newton meters. And it's always good practice to have 2 separate people checking these connections here and using different colors of pens. And then just put a mark on there saying, okay, I have checked this connection here with 4 Newton meters, and then the next person comes and makes a blue mark on it after testing again with a different tool. So we have now checked all these ones. They are all fine. Let's take out the circuit breaker. It's this one and this one. Come on, how long are these screws here? Oh wow, they are very long. And then we can use an Allen bit with the torque wrench and check these connections as well. Alright, the torque meter is set to 4 Newton meters still, and we see what we will get. And I re-torque these circuit breaker screws here. 4 Newton meters. Yeah, that's a bit more. That's like 5-6 Newton meters. Then the actual screw starts spinning. 7. This one has actually 7 here or even more. So honestly, I don't think they have actually torqued these settings here. They just tightened these connections. But these breaker connections here definitely had different torque settings. This was 6 and this was more like 7.5. Does it matter? Not really, but it is about the consistency when they build this battery box here. And here as well, there's no mark on the screw, so I'm not sure if this one has actually been tested. Well, obviously not, because otherwise they wouldn't have different torque settings, right? So there is still a bit of improvement necessary here to get this right. And while we got this breaker out here, we can also see the specifications here. It's 550 volts DC and 20 kiloamp of braking capacity. So this breaker is a huge improvement from the breaker they have used in the old battery box. That is a breaker, this one is a toy. And then here on the back of the breaker, these are actually the bolts which are going through the front panel, all the way through the breaker and coming out here. They've got a nut here on the back, holding the circuit breaker against the front panel. But look how long this bolt is. Jeez, I mean, can we get something smaller, something more suitable for this? I'm just complaining here on a high level, but still, I mean, I'm sure they've got suitable screws in China, right? This is like 20-25 millimeters too long. So, and while we are in here, these are the holding screws for the display. It's like a bit of a hook, and then you put in this screw and tighten it with this wheel here. So actually the screw sits against the panel here and it is holding in the display. I think this is a very dirty solution. I know this is common with these displays. I mean, come on, we've got 2024. Is there not a better solution to hold a display in place? I don't know. I just don't like it. What have they done over here? Oh yeah, in the old box they had only these angles with screws. So that's a much better solution actually. There you can see it. but I think these are the original holders coming with a display. I'm just not a fan of that. But okay, it is what it is. Okay, that's the easy part, right? And now it comes with 4 epoxy boards only. So front, end, front, end. So obviously, as per design, they have not included any epoxy sheets in between the battery cells, only the sticky foam, the EVA tape. Let's have a look how the old battery was designed. I think we've got epoxy sheets in between here. But these epoxy sheets these days comes with the cells, usually at least. I would always recommend to use an epoxy sheet and an EVA tape in between each of the cells. So we have here 16 cells EVE LF280K. Interesting sticker, I've never seen this before. Warning, the cell has potential hazards. Failure to comply with these warnings may result in multiple disasters. Wow, I like it. So these cells have been delivered by Yixiang as well here, EVE 280K. Andy, why didn't you buy the MB30 or MB31, which is the newer version? More capacity, same dimensions. Well, if you're in the market for new batteries, have a look at the price. EVE LF280K are super cheap now at the moment. The warehouses are still full of these 280K cells and everyone wants the newer MB30, MB31s now. So clearance sale, right? Very good pricing for 280K cells. Hence we're going with these ones this time. And they come with these double terminals welded on by Yixiang. These are not coming from EVE directly. Yixiang has welded them on. And the quality of the weld is pretty good actually. So I've checked all the cells. I've also pre-charged all the cells to 3.4 volts. And the quality is really outstanding. Super flat, no belly. Oh, they even got a sticker on the side here. 308.8 ampere hours. Wow. Okay, now I'm really keen to read all these stickers here on the side. I haven't seen them before. Okay, give me a moment here. Let's have a look what's going on here. 308.9, 309.3, 3087, 3087, 3088, 8.3, 7.9, 9.1. So I think the smallest one here, 307.4. Yes, that is the lowest one. For a 280 ampere hour, and we're getting 307.4 ampere hours out of it. And the highest is 309. So all these 16 cells here differ within 2 ampere hours, at least from the sticker here. So at this point, I'm not sure if these stickers are coming from EVE directly from the manufacturer, from the factory, or if Yixiang has put them on. Wow, these are huge high capacity cells for a very small price. So check out the links down under the video and on my website for these special bargains here, LF280K from EVE or the MB30, MB31, which have even higher capacity, up to 335 ampere hours I've seen. Totally nuts. And I've also asked Yixiang if they have used anodized material here for these terminals, and they said, well, they said actually not yes or no. They said we have used the same material as EVE uses. So let's see, because the surface probably doesn't come through in the camera here. The surface looks like not pure aluminium. It looks like it has some coating or something on it. I couldn't feel anything during charging these batteries here. So the charger just connected fine with a clamp and charged up all the batteries, so there was no bad contact or something. But here we want to see. See, I've got no reading. Now I've got reading. Now I haven't. See? Tick, tick, reading. Tick, tick, reading. 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 No reading. 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 What do you think? Reading. No reading. No reading. No reading. And if I poke a little bit further, nah, we still have no reading on this cell here. Wow, look at this, huh? What is going on here? Negative, positive. Now you've got reading. Now you've got reading. No reading. See there? Reading. Reading. 2 point, that was a bad reading. 3.3. Okay, and number 4. Reading. Reading. I don't think they are anodized actually. Otherwise we would see more accurate readings. This is directly the terminal. No, I think they are fine. I don't think they have used any anodized material. But this one was a bit strange here, right? Today again, no reading. Yeah, no reading. So I need to twist the cables a bit and then we've got reading. Probably I should polish all these contacts here before we actually connect them. What do you think? I still got all my metal polishing material here. Yes, the good old polishing times. So the cells are coming with 3 of these epoxy sheets and a bag full of bus bars and screws as always. They are obviously bus bars for these double terminals with 2 connectors on each side, but they are not flexible. So and then we basically just follow this picture here in this booklet, starting with battery number 1. Hang on, where's number 1 here? On this side, negative left, positive right, and then alternate with each battery. So the Yixiang Do-It-Yourself box comes with 4 epoxy sheets and 14 of this EVA tape. So they actually don't plan to put any EVA tape at the end and front of each row, but only using the epoxy sheets in these positions. I've got heaps of these sticky foam here in stock from other installations, so I probably put these ones here at the front and beginning of each row, so we have a cushioning on both sides for each battery cell. Just sounds better to me, really. So we're starting here at the front with a epoxy sheet and a sticky foam. Yeah, where are you? I really don't care anymore to glue these sticky foams onto the cells or epoxy sheets. I just put them in as they are with the paper here on the back, so they are actually non-sticky, but the result is absolutely the same. Okay, and then we start with cell number 1. Boom, negative on this side. Then we use the next epoxy sticky foam and the cell the other way around. Negative, positive, I did it wrong and nobody said anything. Negative, positive, negative, positive, and so on. Just follow this picture. Yeah, just follow this picture in this booklet. It tells you how to orientate these cells inside the battery case. Brilliant, very good. So, and now always comes the fun part, compression of the cells. Oh yeah, baby. Okay, we've got 6 screws here at the front, and I think we can almost screw this all the way in because the sticky foam will actually compress a lot, right? So let's give it a try and see how far we come. Starting with the top here, you can see how all the cells come together now. Okay, here, bottom, this side. So for these EVE cells, recommended is 300 kilogram force of compression, and you can achieve this actually with 1 M6 screw torqued with 3 Newton meters. Yeah, this already gives you 300 kilogram of force. It is unbelievable. But with a sticky foam put in between the cells now, it makes it actually unpredictable how much force you get on each cell. So with this case, I wouldn't be too bothered. and we screw in the compression plate all the way in, yeah, because the EVA tape will compress in between the cells, and we can still move the cells here. If I pull on this, I can still see the EVA tape moving, and this bit of cushioning in between the cells gives each cell now enough space to actually expand and contract again. So this works out pretty well. Interesting. Remember in the previous version of the Yixiang Do-It-Yourself box, with these PCBs here, we had some issues with these screws. Actually, there was a possibility that the screw head is working itself through the insulation, touching one of the tracks here of the balance cables, and then make a short between this cell, whichever is connected to this track, and the actual metal here, the metal case. And you can see this screw here is fairly close to this track. There's one close to both tracks. There's one close to this track, and so on. And they have kind of limited this problem here with epoxy washers underneath the screws. But in the new version now, they have only supplied 3 metal screws, and they are still very, very, very close to a track. The same here, very close. These ones are fixed. That is good. That is a bit too close for my taste. And on the underside, it is all good. Got enough space between the holes and the tracks. They have actually changed the layout of the PCBs slightly but the problem is still there. See, especially with this one here, why is the track not going around this hole in a wide, nice curve, right? And here the same. So this is something which is still not fixed. And no epoxy washers this time. Nothing. And only 3 screws. Even there are 6 holes. Then I just discovered another quality issue here. I could actually see a bit of metal here on these cables. See the white one and the first red one on the 3rd connector. And when I pull this red cable, the actual contact comes out. Look at this. I've got it here in my hand. I cannot quite do the same with the white one. Oh no, it comes out as well. Yes, it comes out. So I'm not sure what's going on here with this contact. So whoever made this adapter cable here, so black and white is for the temperature sensor. Looks like they are not. There is a tiny little hook which you need to bend a bit, and then it clips under this plastic here. Yeah, this is not there. Okay, let me fix this here quickly and then we move on. I guess whoever pushed in these connectors here didn't pay attention, and it pushed out these 3 pins here again. So they are now all connected correctly. That's a bit of a bummer, because this is not an original JK cable, so someone made this adapter cable and forgot to put this spiral wrap all around the cable here. But quality control should have picked this up, right? I'm just checking the other cables here as well while I'm here, but they all seem to be fine. Yeah, actually it cannot happen with these cables here because they're all glued in. Oh, where are you? Here. See, they are glued in, so they cannot come out. But these ones here, they actually can. Interesting find. And I only found this problem with the cables because I was checking if we still do this double connection situation there between cell 8 and 9. And yes, we do. And then I checked the cabling. Yeah, last one of the 2nd connector and first one of the 3rd connector. Hang on. First one of the 3rd, I can see the cable there. And then I saw the cables of the other 2 as well. So 3 cables were out here on the 3rd connector. Insane. Yes, we still do this double connection between 8 and 9. I really need to ask Yixiang why they have such a design and need and don't need this double connection between 8 and 9. So I've now connected all the bus bars, double bus bars to the battery terminals, including the balance wires and also temperature sensors where they belong. I haven't put in the last bridge over there because I wanted to show you. So these are all flexible copper bus bars here, multiple layers, makes it flexible in this hump. This one here is aluminium. Yeah? That's an aluminium bus bar. The resistance of this bus bar is maybe actually smaller than one of these bus bars, just because of the larger dimensions. But it is interesting they put a piece of aluminium in here. Okay, and in the final step we can actually mount the front plate now back to the actual case, connect the P negative to our bus bar and the battery positive to the last terminal over here. Here connects the last balance cable as well as the positive for the BMS. And this one doesn't have a connector in between anymore, it's just a piece of wire now. Here you can see it here, this one has a connector. So if you want to disconnect the BMS, you just disconnect the cable, the positive here, and the BMS is dead. You can't do this here, you have to actually unscrew this cable. Okay, that's another change. Maybe this cable is cheaper than the one with the connector. Okay, I thought I can finalize the battery before I pick up the camera again, but no. So, two things I found. The main positive coming from the bottom of the circuit breaker to the main positive of the battery here is a bit short. It fits. I can put a screw in here, but it is really tight around the corner of the BMS there and then tight again under the circuit breaker. So if they make this like 50 millimeters longer, we've got a nice bend here. There's so much space. We've got a nice bend here and coming straight onto this battery terminal. Here I need really to push it hard to get this screw in, and even worse is the one here on the P negative. Either use a bended ring lock, 90 degrees downwards, or make this cable longer. Look how much space we have here, and the cable is so short. I don't know why. See, these ones are nice and long. Yeah, this one here, nice and long, gives you enough slack to build this up, but this one here comes out of the ring lock and goes straight away down, and this is tight like a guitar string. I don't like it at all. So my friends, I've got everything connected so far. Well, we need to talk about the cable sizes used by Yixiang in these batteries. So let's start on this side here for the negative. They've got 6 gauge wire, 2 of them in parallel, which makes around 25 square millimeter cable. That is good for 97-100 amps max. Right? We have a 250 amp circuit breaker in here. So if we keep pushing 200 amps through these thin cables, we will need this fire extinguisher. And even worse for the positive, because the positive is a, what was it, 4 gauge wire, exactly, 4 gauge wire, which is around only 20 square millimeter of cable. So this one will actually start burning first. And for a 250 amp circuit breaker, they need to have at least 95 square millimeter of cable. So I'm not sure why they use a 20 millimeter cable instead of 95. So these cables need to be longer and need to be upgraded to the correct size to match this circuit breaker. I know these are silicon cables, so they can carry a bit more current, and they're also very short. But still a 25 square millimeter cable and 200 amps or even 250 amps, I don't like. So, and now comes another interesting part of this battery box here, which is the fire extinguisher or aerosol, what is it? I don't know what's called. This is actually not a cable, it is another like temperature probe or something. And in this heat shrink here I can actually feel 2 cables or so. So I think it's only measuring the temperature on this side as well as over there. And then once the temperature is exceeded, it starts something, I don't know. So there must be a battery inside, maybe a 10-year lithium battery, one of these small button cells. But yeah, that is quite interesting. So leave your comments down below if you want ND2 to do a test with these aerosol fire extinguishers, because I'm not going to do it. So in this one only goes here somewhere on the other side and stays somewhere over here. And I believe this is why we have these small cable ties here. Shit! You know what we have forgotten? To scan all the QR codes of these cells. And now I can't reach them anymore. So I have to take off some of the balance cables, flip the PCB, and then I've got access to all the QR codes and scan them. I'll do this later, and I'll show you the results of these QR codes in a table when we do the capacity test in the next video, because I want to see if we get really 305 ampere hours out of this battery here at a 0.2C discharge. That'll be insane, right? So I also managed to gain a little bit of cable here in this situation, in this area. I basically undid the screws on the BMS at the bottom here and could move the cable so they are pointing to the side a little bit. So this gives me another 10 millimeters and it is not as tight anymore. But still, I mean, for the space we have in here, 50 mil here, 50 mil there, and everything is good. If we have the right cable size, of course. Unless your cable is your fuse. Alright, so all the screws of the bus bars to the terminals are all torqued with 4 Newton meters. Even they recommend like some insane, here, 8 to 9 Newton meters of torque to tighten the battery cell screws. I think that's a bit too much. Well, these double terminals here, they can take 8 to 9 Newton meters, no problem. But I don't know. I always, since the beginning, since my first battery build in the plastic tub, I always used 4 Newton meters and never had an issue with that. So, up to you. In the last step, we just need to connect the BMS cables to these boards now. And we start with the main negative with this one. Why, this is actually number 3 and 4. No, it's not. It's only labeled 3 and 4. Okay, I have to put my finger underneath here, otherwise the PCB will bend. And we don't want to have a bended PCB, right? Same over here, see it bends down. Alright, cool. Positive, negative, everything is torqued, everything is marked. Okay, let's turn it on and hope for the best. Yes, there we are. 0% or 99%. I think it's rather 99%. The alarm comes from the password we need to change on the BMS. Alright, let's test the circuit breaker here. Small Allen key. Oh. Oh. Oh God, is that... Of course it only works if it's turned on, right? It was turned off. Yes. Now it works. Good old JK BMS. Because all the dip switches are off, so there should be a 0 at the end. But it needs to be a 200 amp BMS. I wonder if it's this at the top here with the 40. Yes, it is. Have they renamed the BMS already? Okay, lithium iron phosphate. Boom, it was sitting on LTO. And now we have to set it up. Just curious what version they deliver it with. 15.29, so relatively new. That's fine. It will get the new 15.33, I think. Okay, all cells are around 3.36 volts, 3.34. Why is the balancer already on? Why is it already balancing? Ah, 3 volts. 9, 4, 5. Okay, no balancing here. All right, pretty cool. Everything seems to work fine. And, well, this basically concludes the build of the new Yixiang do-it-yourself battery case box situation with a new circuit breaker, fire extinguisher and some slightly changed design. Okay, actually I made a bit of a mistake here because I should have put the lid on this battery here, put this battery case on top of this battery and then start putting all the cells in. Now I have this heavy beast here sitting next to the actual location where it needs to go. And yes, all these battery cases, they have actually little feet. You can see them, little feet underneath. And these feet go into the holes of the next battery underneath. so you can stack them up and they are not moving. And then you use this hook and latch system here to secure them again. But before I get the crane out and stack these two batteries on top of each other, there is something far more important. 2, 6. Thank you so much for 98,526 subscribers. That is insane. And thank you very much to all these generous donors. You know, buying me a beer so I can calibrate a spat. It's very important in these hot conditions. Thank you very much for all your donations. And thank you very much for leaving all your comments and likes and sharing these videos everywhere. This all makes them possible. Otherwise we wouldn't be here and building batteries in the garage, right? And I wouldn't be sweating that much. Alright my friends, let's wrap up this video here about the Yixiang do-it-yourself battery box. Looks actually good, right? What I noticed is though, they have now the positive terminals on the left, while before it was on the right. Only Seplos does it this way. Negative left, positive right. Everyone else is on this standard now. So yeah, if you have an old one and a new one, you have to find a way to route your cables from one positive to another positive terminal here. And I also noticed they have actually improved these covers here. They come now with little handles here and clips. You can easily take them off. While the old ones were all a bit... you have to twist and break them off halfway. They've got these little plastic hooks inside and then snap back in on the terminal. I really don't like these ones here. That's pretty cool actually. So, improvement. So while we were building this battery box here, I've already spoken about the pros and cons of this battery box. So I showed you all the details I could find, positive and negative. But for the sake of this video here, let's do a quick summary, wrap this all up so we can all go home. So I have already sent all these complaints to Yixiang and they have already replied. So I will put their replies here in this summary as well. Okay, let's start with the cons. BMS cable numbering. So I didn't like this numbering 3, 4. You've seen it in the video. The numbering is not in the right order. I don't know why. For me, it looks a bit lazy not to do that. Not a big thing, but I wouldn't do it. The BMS and connection torque settings were a bit inconsistent, so I could measure different torque settings. Yixiang said they are doing it by hand, not with a machine. Well, if they would do it with a torque wrench, they would all have the same setting, right? The same for the breaker connection, top and bottom was a different torque, and there was no marker on any of the screws inside, so we don't know if they have been checked or not. So all of these complaints about the screws and connections and torque settings, this is actually a quality control issue. So for me it looks like nobody is actually checking the quality of these boxes anymore after they have been built. I haven't shown this in the video actually here, but the cable on the underside of the breaker has actually a very tight bend in it. So it comes out of the ring lug and then bends in a very sharp angle. So I don't quite like this. Maybe they can find a better way to do that. The balance PCBs on top of the battery cells here, I've got 6 holes and only 3 screws have been supplied. Yixiang says it will hold with 3 screws. Of course it does. Honestly, how much are 6 of these small M3 screws, right? Then still these tracks of these PCBs are very close to the holes. I don't know why we are still dealing with that. This was already half fixed in the older version of the battery box, but now we are back to metal screws, very close to tracks on this PCB. Yixiang replied that nylon screws are not strong enough, so it's a bit of contradicting what they're actually saying. I think nylon screws will be perfectly fine for that. The positive and negative cable are too short. Even there's so much space in this front compartment where the BMS is. Yixiang said if they make them longer, we have an increase in voltage drop, and there's also not enough space in the front to deal with longer cables. I would disagree to that. In my opinion, the cables are far too thin for a 250 amp circuit breaker. I know these are silicon cables, yeah, and Yixiang actually claims these cables are good for up to 200 amps. But again, we've got a 250 amp circuit breaker and we have a 25 millimeter cable for the negative and a 21 millimeter square millimeter cable for the positive here. And actually, so if you have a look online for current carrying capacity for silicon cables, so I'm using here a more conservative table because I think this is a safety issue. And when we have a look here, let me put this on the screen here. So when we have a look at the 25 millimeter cable here, under best circumstances, so the cable is actually installed in open air. We've got a current carrying capacity of maximum 129 amps for a 25 millimeter silicon cable, yeah. This is for ambient temperatures up to 150 degrees. But we are dealing here with 250 amps. So 245 here is at least a 70 mil cable, 3 times more than what they selected. But if you look for installation of these cables in tighter spaces, you need to go to group 1 or group 2. 250 amps demands at least a 95 millimeter cable or even a 120 millimeter cable. So this 21 or 25 millimeter cable they have used here, definitely not enough to carry 250 amps. I know this is an extreme case, so the circuit breaker will trip at 250, roughly. You know, this is a safety device. So if your BMS, for whatever reason, does not trip at 200 amps, the circuit breaker needs to prevent the unthinkable. So it can actually occur that you have 250 amps through your faulty BMS and through these thin wires of 20 and 25 millimeter. Yeah, it's a bit of a shame because the previous box here had these flexible bus bars inside and they have a far higher carrying capacity than these silicon cables they have put in now. But guys, let me know in the comments down below what do you think about a 21 or 25 millimeter cable for 250 amps. Even they are short and even they are made from silicon insulation. So again, I don't agree with that. Alright, on the positive side, the boxes are from a very high quality. Very good workmanship. I like the paint, I like the welding inside. All the holes are lining up. There's none of these screws is actually sticking out here. This is all well built. So really, really good. The new one as well as the old one. Same quality. Perfect. Nice. The booklet manual with the pictures inside, a bit of text. The QR code you can scan to watch the video how to install the battery if you have any questions. Super, super good. This is what we are always wanted from all the other manufacturers, right? Just a small piece of paper with the instructions. No QR code, no download, no searching online. It is just right there. Fire extinguisher. I put the fire extinguisher in here as well. It is a pro. But is it a reason to buy especially this do-it-yourself box instead of another do-it-yourself box? I don't think it is actually a big thing, but they put it in, so yeah, it's good. I really like this design of the compression plate here with 6 screws. They are long enough, you just loosen them, put your cells in, tighten them again, and you're done. You don't need to measure any torque or something. With the EVA tape and the epoxy sheets in between the cells, it fits perfectly and gives them a nice and snug fit. So it's a really, really good design. We now have a good sized circuit breaker here instead of the old flimsy one we had in here. This is a really nice upgrade. It has sufficient breaking capacity of 20 kiloamps now. So nice. And I've got the vent holes here as a positive as well. This is a new feature. I'm not sure if this is actually necessary to have ventilation holes. How warm or hot does it actually get in the front part of this battery under normal circumstances? I don't really know. Is it necessary? Leave your comments down below. Alright my friends, there you have it. So this is basically what you get when you buy one of the Yixiang do-it-yourself battery boxes. Yeah, as always guys, leave your comments down below. What do you think about this new version of the battery box? Has it improved? Has it gotten worse? So thinking about all the pros and cons and considering also their replies to my concerns, I would give this do-it-yourself battery box here a 3 out of 5. So actually 1 frog less than the previous version. And this is mainly because of safety concerns about the cable length and moreover the cable size they have used inside this battery box. But again here, this is just my personal opinion, especially considering the cable sizes inside, which I think is the main concern and even a bit of a hazard. Alright my friends, this is all I have tonight. As always, I'm very keen to read your comments and your thoughts and opinion about the do-it-yourself battery box from Yixiang.